Hello guys, welcome on Tesla Adventures. This is a type 2 problem in which we will be dealing with the problems which are on variable acceleration and variable velocity. So let us see the first concept illustration problem. You can see that for a particle which is restricted to move only on x-axis, the x coordinate is linked with time with this equation, and we have to find out the average velocity, average speed and average acceleration in 2 seconds. Okay, so first of all, let us see that let us analyze this problem, and let us identify some statements as correct or incorrect. You can see that the first statement says that equations of motion are valid in this equation. So you can see that the velocity will be dx by dt, and dx by dt is 4t plus 4. Okay, and you can see that the highest power of time in the xt equation is 2, and the highest power of time in the vt equation is 1. And if we find out the acceleration, then it would be 4. So we can say that the highest power of time in at equation is 0. So we can say that acceleration is constant. And when acceleration is constant, then equations of motion are valid. So the first statement that the equations of motion are valid in this motion is true. So this is true. Now the object never changes its direction. You can see that this is a one-dimensional motion. The acceleration is along in the direction of velocity. So if A is parallel to V, then the object will never change its direction. In fact, acceleration is also constant. So we can say that object will never change its direction. So this is also true. And the third statement, that the distance and displacement are equal in magnitude. Obviously, when the object is moving on a straight line in such a way such that its direction is never changing, then obviously the distance and displacement are equal quantities. So this is also correct. So we have analyzed this problem, and we can see that the formula of average velocity, V average, is displacement traveled upon time taken. Many students directly use the displacement upon time formula, which would be wrong, because you can see that at t is equal to 2 seconds, x will be equal to, this is 8 plus 8 plus 1. So x will be 17. So many students gives the answer that V average is equal to 17 upon 2, which is wrong in fact, because 17 is the final displacement. It is not the traveled displacement, because initially at t is equal to 0, the initial displacement was 1. So the traveled displacement delta x is 17 minus 1, and the V average would be equal to 17 minus 1 upon time, which is 2. So this is 8 meters per second. Now the average speed, V average, this is average speed, this is average velocity. So average speed and average velocity will be same in magnitude, because distance is equal to displacement. We have already discussed that distance is equal to displacement, as the direction of motion is not changing. Therefore, V average, we can say that it would be distance traveled. So distance traveled is again 16 upon time is 2. So it would be 8 meters per second. And average acceleration is equal to V final minus V initial by time. So you can see that the final time at which we have to find out these quantities is 2. So the final velocity would be velocity at 2 seconds. So V at 2 minus V at 0 upon time. So average acceleration, A average, is V at 2 would be we can substitute the value of time as 2 in this equation. So 2 into 4 is 8 plus 4, which is 12, and minus the initial velocity was 4. You can substitute 0 here, and the time taken is 2 seconds. So it is equal to 8 by 2, which is 4 meter per second square. So this is the average acceleration. Okay, so this was the first concept illustration problem in this kind of questions. And there is a evidence that the body will never turn around, or it would never change the direction. You can see that there is no negative sign in this equation. So velocity time equation would also have all positive signs. So velocity would not be 0 at some real time. So which means that body will never turn around. Now let us move on the next concept illustration problem. This is a very important concept illustration problem because it has a twist in it. You can see that there is a negative sign here. So we can directly identify that the body would change the direction and it would make a U-turn at some time. We have to find out the average velocity, average speed, and average acceleration in 2 seconds. First of all, we can see that the highest power of time in this equation, xt equation, is 2. So if we would differentiate the displacement twice with respect to time, then we would be getting acceleration. And in this case, the acceleration would be coming out to be constant. So we can say that equations of motion are valid in this problem. And first of all, let us see that what is the twist. So if we find out the velocity in this problem, then it would be 4t minus 4 I cap. And you can see that at t is equal to 1 second, velocity is 0. So first of all, if you are watching some negative sign here, so you should first of all find out the velocity, and you should find out the time at which this velocity will become 0. So we have calculated the time at which this velocity would become 0. Now you have to listen my words carefully, and you have to always trace the particle at 3 instants. The first instant is always t is equal to 0. The second instant is the time when velocity is equal to 0, which is t is equal to 1 second in this case. And the third instant is the time which is given in the question, which is 2 seconds. Okay, so you have to trace this particle at 3 instants of time. When initial instant is t is equal to 0, the second instant is the time when velocity is 0, which is 1 second in this problem, and the third instant is when we have to find out the quantities. So we have to find out these quantities in 2 seconds. So the third instant of time is 2 seconds. Now let us trace this particle. So you can see that at t is equal to 0, x was equal to 1. You can see that this x is 1, and at t is equal to 1, x is, you can see that this is 2 minus 4 plus 1. So 2 minus 4 plus 1 is minus 1. So x is equal to minus 1. And at t is equal to 2 seconds, this is 4 into 2, 8, and this is 2 into 4, 8 plus 1. So this is x is equal to 1. So you can see that this particle is moving in such a way such that at t is equal to 0, it was at x is equal to 1. Then at t is equal to 1 second, it was at x is equal to minus 1. And then at t is equal to 2 seconds, it is again at x is equal to 1. So you can see that its motion would be like that it is moving in the backward direction first of all, then it makes a U-turn, and then it again moves in the forward direction. So you can say that the distance moved by the particle is this plus this, and this is 2 and this is 2. So distance is 4, and the displacement moved by the particle is 0. So the average velocity, or we can say that the average velocity is 0, but the average speed is 4 upon time, and the time taken by the particle is total 2 seconds. So the average speed is 4 upon 2, which is 2 meters per second. Now the average acceleration, we talk about the average acceleration, it is v final minus v initial upon time taken. So you can see that the final velocity is that final time is that 2 seconds. So we can see that we have to write down the velocity at 2 seconds minus velocity at 0 seconds upon the time taken, which is 2. So velocity at 2 seconds, you can substitute the 2 here, and you can see that it is 8 minus 4, which is 4. So velocity at 2 seconds is 4, and velocity at 0 seconds is minus 4. So this is minus 4, and the time is 2. So you can see that the acceleration, average acceleration will be 8 by 2, which is 4. Now you can also see that the acceleration which we are getting by differentiating this velocity equation is also 4, and this is constant. And if acceleration is constant, then we can say that the average acceleration and the instantaneous acceleration is always same. Okay, so instead of calculating the average acceleration from this formula, you can directly say that average acceleration would also be 4, because acceleration is constant. So again, I am concluding this problem, and I am again speaking the highlight, and you can, first of all, you have to identify that whether the direction would be changing in this problem or not, which you can identify by this negative sign. If there is any negative sign that exists in the xt equation or vt equation, then you must check that whether the direction is changing or not. Let's suppose that this negative sign would be here, and this would be positive. Then v would be 4t plus 4. Then velocity would never be 0. So direction would not change in that case, but you have to check first of all that whether the body will be at rest or not at some time. You have to find out the time at which velocity would be 0. So we have calculated this time as 1. And finally, you have to trace the particle at 3 instants of time. The first instant is initial instant, which is t is equal to 0. The second instant is the time when velocity is 0, and the third instant is the time which is mentioned in the question. In some questions, if velocity is 0 twice, so you have to trace the particle at the 4 instants. Now you can trace the particle, and you can find out the clear difference between distance and displacement, and then you can find out the further quantities which is being asked in the question. Now let's move on the next concept illustration problem. This is another concept illustration problem, and as you can see that the displacement in this problem is given as x is equal to t cube upon 3 minus 3t square plus 8t plus 4. Okay, so we have to consider the motion from t is equal to 0 to t is equal to 5, and in this duration that s1 is the total distance traveled and s2 is the distance traveled during retardation. Okay, so we have to find out s1 upon s2, as well as we'll be finding out the displacement also. So first of all, you can see that there is a negative sign here, so we must find out the equation of velocity first of all. So it would be t square minus 6t plus 8, and if you will equate it to 0, then you can see that it is t minus 4t minus 2t plus 8 is equal to 0. So this is t minus 4, and it would be t, in fact will be taking minus 2 common, so it would be t minus 4. So you can see that t is equal to 4 and t is equal to 2 are the two instant of time when velocity is 0. So let us first of all use the basic concept that we have to trace the particle at 3 instants. The first instant is t is equal to 0. The second one is t is equal to 2 and 4 when velocity is 0. And the last one is t is equal to 5. Okay. So let us trace the particle. Let us see that at t is equal to 0, x is 4. You can see that t is equal to 0, x is 4. At t is equal to 2 seconds, you can see that x at 2 is equal to, this is 8 by 3 minus this is 12 plus 16 plus 4. So this is 8 by 3 plus 4, in fact plus 8. So this is 32 by 3. Okay, so x is equal to 32 by 3 at t is equal to 2. At t is equal to 4 seconds, x is equal to, this is 64 by 3 minus 48 plus 32 plus 4. Okay, so this is 64 by 3 and this is minus 16 plus 4. So minus 12. So this is minus 12 and 64 by 3 minus, this is minus 36 by 3. So 64 minus 36 by 3 is 28 by 3. So it is 28 by 3. And at t is equal to 5 seconds, let us again find out what is x. So at t is equal to 5 seconds, you can see that x is equal to, this is 125 by 3 minus this is 75 plus this is 40 plus 4. So x would be equal to 125 by 3 minus 31. Okay, so this is x is equal to 125 minus this is 93 by 3 and it would be 32 by 3 again. Okay, so this is again x is equal to 32 by 3. Now let us again trace the particle at this time and let us find out what is happening. Now you can see that now you can see that at t is equal to 0, x is 4. This is t is equal to 0 and at this time x is equal to 4. So at t is equal to 2 seconds, this is 32 by 3 which is almost 10.66. So t is equal to 2 seconds, this is x is equal to 32 by 3. At t is equal to 4 seconds, let us mark it far away. At t is equal to 2, x is equal to 32 by 3. At t is equal to 4 seconds, x is 28 by 3, t is equal to 4 seconds. And at t is equal to 5 seconds, x is again 32 by 3. So the motion is occurring like that it is starting from this point and it is going in forward direction till t is equal to 2. Then velocity is 0 at this point. Then it makes a sharp turn and it moves to x is equal to 28. Then again velocity is 0 at this point. And then it again makes a sharp turn and again reaches to this point. Okay, so you can see that the total distance traveled is this one, and this one. So you can see that this is 4 by 3 and 4 by 3. So it is 12 by 3 which is 4 and this one. So S distance is equal to this is 4 plus this one. So this would be equal to 28 by 3 minus 4. So 28 by 3 minus 4 would be equal to 16 by 3. Okay. So this is 16 by 3. And this is again, you can see that it is 28 by 3. So the total distance traveled is 28 by 3. And the displacement traveled, this is displacement, it is this one. So this is 32 by 3 minus 4. So it is 20 by 3. Displacement is 20 by 3. And again we have to find out the time in which the distance traveled during retardation. Now for that we have to find out the acceleration, and acceleration will be equal to, you can differentiate this equation. So acceleration would be 2t minus 6. So this is 2t minus 6. So if you can see that at time 3 seconds acceleration is 0, and when t is less than 3 seconds then acceleration is negative, and when t is greater than 3 seconds then acceleration is positive. So you can see that till 3 seconds acceleration is negative, you can see, and beyond 3 seconds acceleration is positive. So you can see that at some time 3 seconds, let us again find out the x. So at 3 seconds x would be equal to, this is 9, this is 27, and this is 24 plus 4. So x is equal to 10. You can see that at 3 seconds x is equal to 10. This is minus 18 plus 4 is minus 14, and minus 14 plus 24 is 10. So x is equal to 10, and x is equal to 10 will occur somewhere here. So let us again draw the diagram. You can see that so you can first of all write down the time. We have to mark the time 0, 2 seconds, then 3 seconds, and then 4 seconds, and then 5 seconds. So first of all, at t is equal to 0, x is equal to 4. Then at t is equal to 2 seconds, x is equal to 32 by 3. So this is t is equal to, x is equal to 32 by 3. And at t is equal to 4 seconds, in fact 3 seconds, this is 10, x is equal to 10. So t is equal to, velocity is 0 at this point, t is equal to 3 seconds, x is equal to 10. Then t is equal to 4 seconds, x is equal to 28 by 3. So t is equal to 4 seconds, x is equal to 28 by 3. And velocity is again 0 at this point, and at t is equal to 5 seconds, x is equal to 32 by 3. Okay, so we have already marked the motion. So you can see the motion is like that it is going in the forward direction, and then it makes a U-turn and it moves in the backward direction. Then again it makes a U-turn and it moves in the forward direction. Now I am marking the acceleration. You can see that in this region, till 3 seconds, acceleration is negative. It is in backward direction, and beyond 3 seconds, acceleration is in forward direction, positive. So you can see that when the object is moving from t is equal to 0 to 3 seconds, acceleration is negative. And therefore the retarded motion is from 0 to 3 seconds. So the distance traveled from 0 to 3 seconds is equal to this is 10 minus 4, which is 6, plus you can see that beyond 3 seconds in this region, you can see that in this case velocity is again, in fact this is also a retarded motion. From 0 to 2 seconds it is a retarded motion because acceleration is in negative direction. So this is also, this must be counted, so it would be 32 by 3 minus 4, which is 20 by 3. So this is 20 by 3, 0 to 2 seconds, retarded motion, 20 by 3. Now when it moves in the backward direction, then till 3 seconds this is an accelerated motion, and beyond 3 seconds to 4 seconds, you can see in this interval of time from 3 to 4 the object is moving in the reverse direction but acceleration is in forward direction. So this is also a retarded motion. So from 3 to 4 the distance traveled is 28 by 3 minus 10. So it would be in fact you can see that 10 minus 28 by 3. So it would be 2 by 3. S2 is equal to 2 by 3. And then it turns back and acceleration is in forward direction. So this is an accelerated motion. We do not have to count this one. So the total distance traveled in during the retardation, distance traveled during retardation is equal to 20 by 3 plus 2 by 3. So it is 22 by 3, and this is S2. So we have to find out S1 and S2, where S1 was the distance traveled and the distance traveled is equal to 28 by 3. So the correct answer of S1 upon S2 will be 28 by 22, which is 14 by 11. Okay, and the displacement which we have already calculated is, I guess, displacement is 20 by 3, yes. Because initial position is this and final position at which the journey ends is this one, 32 by 3. So 32 by 3 minus 4 is equal to 20 by 3. Now we move on the next concept illustration problem.